In this lecture, we will see the introduction of convolution code and drawbacks of the block codes. We have studied the block codes, cyclic code, which converts k message bits per symbol to n bits per symbol. This type of coding is useful for applications having high data rate. In such applications, incoming stream of message bit is divided to form blocks. These blocks are then encoded and code words are transmitted. It is observed that the larger the block length, n reduces overhead and performance is better. But the block length should not be too large as well, because if the block length is too large, then the receiver has to wait for a very long time to allow all the bits in code word to be received. Block codes are having following disadvantage. Number one, a storage is required to be used at the transmitter to store message blocks. Decoding process at the receiver cannot start unless entire code word is received. Due to above two drawbacks, delay gets introduced and therefore the block codes are not suitable for real-time systems which are sensitive to delays. To overcome these problems in the block codes, another coding scheme is developed which uses much smaller blocks of message words. These are known as information frames. Information frames are made up of very few symbols or bits or very small number of symbols, or some generally it is just one single bit. But just current information frame or bit is not used to obtaining the code word frame. Present information frame or bits and previous m bits information or frames or bits are used to obtain the code word. This implies this type of code will use some memory. This type of code is called as tree codes or convolution codes. Now we'll see the block schematic of convolution encoder. Now in this block, one shift register is there. M represent the current message bit, M1 and M2 represent the previous bits, and there is a one logical circuit is used to XOR these bits, and some switches are used at the output to switch a single bit at a time. It consists of shift registers and mod to XOR gates. Generally, three parameters are used to specify the convolution codes: n, k, m. N is nothing but the number of output bits per information frame or per bit. K is nothing but the number of message bits entered at a time in a convolution encoder. M is the order of memory. Now we will see the sum of the terms used related to that of convolution code. First of all, code rate. Code rate is the ratio of message bits to the output bits. K by n is called as code rate. Then constraint length. The constraint length of convolution encoder is defined as the number of times the information bits affecting the output code word is called constraint length, and it is denoted by that of the k. Now we can find out the constraint length by using this formula k in bracket m plus 1, where m is the order of memory and k is nothing but the number of bits entered at a time.